All right, for example 5, it says determine f prime if f of x is equal to x plus 1 over 3x minus 2, where x cannot equal 2 over 3. Hence, write the equation of the tangent to the curve at the point where x is equal to 4. Well, let's solve our f of x first. So we're going to state that f prime at x is going to equal the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is going to be the limit as h approaches 0 of x plus h plus 1 over 3x plus h minus 2, minus x plus 1 over 3x minus 2, and it's all going to be divided by h. Now, when I do this, I need to put them over a common denominator. So what I'm going to do is I'm going to say that I have limit as h approaches 0 of x plus h plus 1 over 3x plus 3h minus 2 and x plus 1 over 3x minus 2. They're completely different factors in the numerator, so I'm going to multiply the first set by the denominator of the second, 3x minus 2. And the second, I'm going to do the denominator of the first one, 3x plus 3h minus 2. And this is all still divided by h or multiplied by 1 over h. This is going to give me the limit as h approaches 0 of 3x squared minus 2x plus 3xh minus 2h plus 3x minus 2 minus 3x squared plus 3hx or xh, let's try and keep it consistent, minus 3x, let's try it again, minus 2x plus 3x plus 3h minus 2. And because I am taking away a 3x squared from 3x squared, because I'm taking away a 3xh from a 3xh, because I'm taking away a negative 2x from a negative 2x, because I'm taking away a 3x from a 3x, and I'm taking away a 2 from a 2, all I'm left with is negative 2h minus 3h, and the denominator is still that complicated, 3x plus 3h minus 2 and 3x minus 2 and h. So I have the limit as h approaches 0 of negative 5h over 3x plus 3h minus 2 and 3x minus 2 times h. Take away the common h, And f prime at x is going to equal -5 over 3x plus 3 times 0 minus 2 times 3x minus 2, which we can simplify just to -5 over 3x minus 2 squared. Now, what are we doing with this? We are taking the point where x is equal to 4, and we are creating the equation. So let's start with f prime at 4 is going to equal -5 over 3 times 4 squared, 3 times 4 minus 2 squared. Which means that this is going to give me -5 over 100, which is equal to -1 over 20, which we know is actually the slope. We can also find what the value of f is at 4 in my original function. So if I'm finding f of 4, then I'm going to say that using this original function, if I took 4 plus 1 over 3 times 4 minus 2, then that's going to give me 5 over 10, or 1 over 2, which means that I also know that I have the point on my graph at 4 and 1/2. And what do we do with this? We put it in slope point form. So let's block this off. And we're just going to carry this information down and say that I have y minus y1, or 1/2, is equal to the slope, -1 over 20, bracket x minus 4. This is going to give me y minus 1/2 is equal to -1 over 20x plus 4 over 20. I'm going to multiply everything by 20 and get 20y minus 10 is equal to -x plus 4. And I'm going to move everything to left and state that I have x plus 20y minus 14 is equal to 0. And there is my equation. So for derivative notation, Leibniz notation is a useful way of representing derivatives. If y is equal to f of x, then dy over dx is equal to f prime at x. If we use this notation to represent the derivative of the function in example 4, we get if f of x is equal to the square root of x plus 2, then that means that dy over dx is equal to 1 over 2 and the square root of x plus 2. An advantage of this notation is that it reminds us of how we found the derivative in the first place. Dy over dx is equal to the limit of the change in y over the change in x. Now remember, this is not a ratio and it is not a fraction. It is just another way of stating what f prime represents. Another advantage of this notation is that both variables x and y are indicated. So if we're working with variables besides x and y, this notation is still useful. For example, if the displacement s of a particle is given as a function of t time, then the velocity is expressed as the velocity is equal to ds over dt. Another type of notation you will see is as follows. The process of taking the derivative of the function is called differentiation. If we differentiate f to produce a new function, f prime, then we would write dy over dx is equal to d over dx of f of x. And d over dx is called a differential operator. So we could use d over dx of x plus 1 over 3x minus 2 is just f prime negative 5 over 3x minus 2 squared. Here are all the ways we can write y equals f of x, or the derivative of y equals f of x. We can call it f prime at x, we can call it y prime, we can call it dy over dx, we can call it d over dx of f of x, we can call it d of f of x, or we can call it d of subscript x of y. And lastly, if we want to indicate the value of a derivative in Leibniz notation, then we use a number a, where we just state x is equal to whatever that a value is. So if I'm doing this using example 5, then I would say that if I have negative 5 over 3x minus 2 squared for when x was equal to 4 is going to equal negative 1 over 20. And that's it for this lesson.